Alrighty, folks. Today we are going to talk about the role that energy takes in reactions. So let's go ahead and get our notes set up. Our topic today is energy in chemical reactions. Our essential question is, how is energy transferred during chemical reactions? And we only have two guiding questions today. What happens to energy during an endothermic reaction, and what happens to energy during an exothermic reaction? Our learning target is I can describe what happens to chemical bonds and energy during chemical reactions. All right, folks, so I want you to go ahead and grab out the handout called Energy and Reactions handout. We are going to be filling this out today in addition to adding a little bit of note information to our notes. So kind of a little back and forth here. All right, let's go ahead and start out with an endothermic reaction. So an endothermic reaction, these are reactions that take energy in from the surroundings. Remember, we learned about endothermic and exothermic phase changes, and so this is just endothermic versus exothermic reactions. And endo in, energy goes in. And so the energy is usually transferred as heat energy, and this causes the reaction mixture and its surroundings to get colder. So you can kind of see in blue here an endothermic reaction where the energy is absorbed from the surroundings and the temperature drops. An example of an endothermic reaction, if you've ever had one of those, it's like a dry ice pack. So when you have it and it's just like it being stored, it's at room temperature and it feels like it's kind of full of all this like grainy material. But then if you crush it and begin kind of like massaging it, first off, it starts to feel like it becomes liquidy inside and it gets really, really cold. Okay. And that's an example of an endothermic chemical reaction because as the reaction is taking place, in order for the reaction to happen, it needs energy. It needs heat energy. And so it is taking heat energy from its surroundings. And when you are holding it in your hands or against your body, it is taking heat energy from your body in order to make the reaction happen. And so that's going to be an endothermic reaction. So let's go ahead and quick look at our handout. And so for the energy in an endothermic reaction, this is going to be an endothermic because the reactants they start at a lower energy and than the products do. So if the products are at a higher energy, that means they gained energy. And you can see right here on our y-axis we have chemical energy. On our x-axis we have the reaction time. So as we go from reactants to products, the chemical energy increases, indicating that energy is absorbed. So this is an endothermic reaction. Energy is absorbed, and the reaction is going to feel cold to the touch. So you have your reactant, you have energy as a reactant, and that those are going to react to form your products. Also, just something about endothermic reactions. You can see we start with this is the example we give as a decomposition reaction here, and this is because in order to break bonds in something, you have to put energy into it. So I always think about it as if you want to break a piece of wood, you have to chop it with your hand and you have to put energy into that wood. That same thing is true for a endothermic chemical reaction. If you want to break a bond, you have to put energy into it. So if you have a reaction where more bonds are broken than formed, then it's going to be endothermic. And we see bonds being broken here. All right, an exothermic reaction. So this is going to be where energy transfers to the surroundings, and this energy is transferred as heat energy, and that causes the reaction mixture and its surroundings to become hotter. So in an exothermic reaction, energy exits. We learned that once again with our phase changes. So a really common example of any sort of exothermic reaction is going to be something burning. So just think about a piece of wood. Yes, you have to put energy into the wood in order to get it started, but once the log begins to burn, it's going to put out so much more heat energy than you initially put in order to get it started. So any kind of burning wood is going to be an exothermic reaction. So let's go ahead and flip back to our handout, and we can see here that in an exothermic reaction, our reactants start at a higher energy than our products end up with. So energy is lost or released during the reaction, and that energy comes across as heat. So This is an exothermic reaction. Energy is released or lost. The reaction feels hot or warm to the touch. And you can kind of see here that energy is going to be a product here. And yeah, so in an exothermic reaction, actually, chemical bonds, when they form, they release heat. So in an exothermic reaction, the reaction is actually going to form more bonds than are broken. So there you go. That is our reaction. All right, folks, go ahead and pause this video and take a 4-question ungraded quiz to see how you did, and then come on back and we'll go through this. All right, a reaction that feels cold to the touch is going to be an endothermic chemical reaction. A reaction that releases energy is going to be an exothermic reaction. A reaction where more bonds are broken than formed. Remember, we have to put energy into a chemical in order to break the bonds, and therefore energy in, endothermic. And a reaction where energy is a reactant, that means that we have to put energy into the reaction in order for it to happen. That would also be an endothermic. So if you answered those questions as such, you would have gotten a 4 out of 4. Very nice. Go ahead, folks, and self-assess on a scale of 1 to 5. How well do you feel you understand chemical reaction types? This is all we're going to be really talking about here, so kind of a quicker lesson. We will continue to work on this in a lab in this unit, though. So have a great day, folks.